Hello everyone. This is the first lesson about the circle theorems. Before I start the concept of circle theorems in actual, we can say the word circle and we can discuss the different terms based on this circle. So if you see here, we have one diagram and the first circle theorem is also given over here. But before that, if you see there are so many lines are drawn, what do these lines mean? We will study about that. So the first thing is chords. Now what is the meaning of chords? Chords are basically the lines. But these are the special kind of lines. So for example, if I am taking this circle and I choose any 2 points on this circle, let's say this is one point on the circle and this is the another point on the circle. When I join these 2 points, this becomes a chord. So chord is basically a line. It is a straight line which joins any 2 points on the circle. Now the second thing comes, chords are, you can take any 2 points. For example, another chord, if I'm taking, I take this point and I take this point. So I join these 2 points. This is another chord. Now there is a very special case of chords when the chord passes through the center of the circle. Now, when I take these 2 points on the circle and when I join this through a straight line, here this is a straight line I draw. This straight line, what I realized that this straight line is passing through the center of the circle. In that case, this line, which is a chord, it will be given a special name, and that special name is diameter. So diameter is a special case of the chords. Chord joins the 2 points on the circle. Any 2 points, they should be on the circle. They can pass through the center of the circle or they do not pass through the center of circle. It does not matter. All right. Now the next thing is segment. Segments are basically related to the chords. Now what happens when I draw one circle? Okay, now we know how to draw a circle. I draw a chord. I take the 2 points and I join them and it gives me one chord. Let's say this point is A and this point is B. When I say these 2 points and I join them, I can say AB is a chord. AB is a straight line, it is a chord. What this chord is doing, this chord is splitting this whole circle into two parts. One is this one, and then the another is this big one. So these two parts of the circle which are inside the circle, these are known as segment. So this is a segment and this one is also a segment. Segment is basically a part of the circle which is obtained by drawing a chord. So when I draw this chord here, and I take this whole part, this whole area, this inside area, this is a segment and then this is the another segment. Now one part is smaller than the other. The bigger one we will call it major segment and the smaller one we will call it minor segment. So we described what is a chord and then we described two kinds of segments. What is the meaning of segment? Two kinds of segment. One is major segment and the another is minor segment. Now, third point is there. Let's say I am taking some points. These 3 points, let's say their names are D, E, and F. These 3 points are in one segment. And then I'm taking another point here, which is X. X is a point on the another segment. X is not in the same segment as the point F, D, and E. So F, D, and E, they are in one segment, same segment, but X is not in this segment. X is a part of the minor segment. Okay. Now let's begin with this rule 1 theorem, because now we understand what is the meaning of a chord and what is the meaning of a segment. There is one third point, that a chord can make angles. So for example, another circle I draw, then I draw one chord. Let's say this is the chord I drew. Then there are two segments now. This is segment 1. This is the segment 1, the first one, and this is segment 2. I take a point in segment 1 on the circumference of the circle. And when I join the corners of this chord to this point, so like this one and this one angle is formed here. Correct? So what did I do? First, I draw a circle, then I draw one chord. This chord divides the whole circle into two segments, segment 1 and segment 2. I take a point in this segment 1 and then I join that point with the two endpoints of the chord. This is point A and this is point B, let's say, and this is point C. Now again I take one more point, I repeat the same steps. In the same segment 1, I take another point and let's say that point is D. Then the same chord, I join the endpoints of that chord with this point. So one is this one and another is this. So there is another angle formed here. When I draw this angle, these two angles, C and D, the angles made at C and angle made at D, they are in the same segment, segment 1. And they are made by the same chord AB. This is very important, that the chord is AB and this chord is making two angles in the same segment. And the rule 1 says, the first circle theorem here says that the angles in the same segment are equal. So that means if I talk about this angle which is made at C, which is angle ACB, is equal to angle ADB. The angle which is made at C and angle made at D, they will be equal. This is the first circle theorem. Okay. You have to remember one thing, that the angles are made by the same chord and angles are made in the same segment. If I am taking another point, let's say here, and I join these points this way by the chord, and I give this point the name as E. So angle E is made by the chord AB, yes, but angle E is not in the same segment as the segment 1. So I cannot say that C and D points, which are in angle 1, which are in segment 1, they will be making the same angle as angle E. So you have to remember in circle theorems why the students find it a little difficult, because there are so many things you need to keep in mind at the same time. Same chord, same segment. If you forget one of the thing, the answer will be wrong, or the whole process will go wrong. Clear? So this is our first theorem of the segments or the circle theorems. Now let's go to the second point. The second rule is basically related to the cyclic quadrilateral. The first thing is here to understand for us is what is cyclic quadrilateral. So cyclic quadrilateral, if I say there are 2 points, there are two terms, cyclic and quadrilateral. Quadrilateral is basically any four-sided shape. Four-sided polygon is known as a quadrilateral. And if the vertices, there are four vertices of this quadrilateral, let's say they are A, B, C, D. If these, all the four vertices lie on the circumference of the circle, then this quadrilateral will be called as cyclic quadrilateral. So cyclic quadrilateral means the vertices, the four vertices of the quadrilateral will be on the circumference of the circle. Now we know that angle sum property of a quadrilateral says that sum of all the four angles will be 360. Sum of all the four angles of the quadrilateral will be 360 degrees. We know that. But in cyclic quadrilateral, where the vertices of the cyclic quadrilateral, where the vertices of the quadrilateral, sorry, they are on the circumference of the circle, opposite angles. So opposite angles are like y and z, and then x and w. So y and z, that is one pair of the opposite angles, and x and w, that is another pair of opposite angles. And what is the property? Circle theorem says that if you add up these two angles, the opposite angles in a cyclic quadrilateral, that will always add up to 180 degrees. And if you add all of these angles, y plus z plus x plus w, you will get it like 360. Y plus z plus x plus w. Clear? This is the second theorem. In today's lesson, we are going to learn about the new terms which are related to circles and circle theorem. And the second thing is we are working on the rules and some questions. The proofs we will do in upcoming sessions. So these are the two theorems. Now the next theorem, which is quite important. After finishing this theorem, we will do some question exercises. Now what this rule says, that the angle at the center is twice the angle at the circumference. What does it mean? Basically, you can assume it like there is a chord. So we draw one circle and I take one chord, and when I draw that chord, let's say this is the chord. Now this chord is going to make an angle at the center. So I take the angle at the center and I join these 2 points. So this is the angle, let's say this is O, this is point A, and this is point B. This chord is making an angle at the center here. Then choose one point on the same segment. This O is in one of the segment. In the same segment, I will be making a point, let's say here on the circumference, and I will join these two together, this point with the chord and points. So one is here and one is here. So here, two angles we are considering. One is the angle made at the center, and another angle we are considering at the circumference. But they both are made by the same chord and in the same segment. In the first theorem, the points were both on the circumference. But now one point I have taken at the circumference and another at the center. So they will not be same. The angles, they will not be same. Here what we will do, let's say this point is C. So what is the relation? That the same chord making an angle at the center, this angle will be always double the angle made at any point on the circumference. So this point is C. So the angle will be ACB, this angle. And this angle, if you twice it, you will be getting the angle at the center. To make it more clear with the rule 1 or the theorem 1, let's say this is another point D. So when I consider this angle which is made by the same chord at D in the same segment, so D and C, they both are at the circumference. So angle ACD, angle ACB and angle ADB, they will be equal because they both are at the circumference in the same segment made by the same chord. But if you see angle D and the angle at the center, so angle ADB, which is at the circumference, will be, or you can say twice of this angle will be equal to the angle made at the center. Because angle made at the center by the same chord will be twice the angle made by the same angle, see at the angle with the same chord at any point on the circumference of the circle. So we can say this angle will be double of this angle as well as double of this angle. Why? Because if this angle is, let's say 45, this angle is 45. So this angle will be 90. Clear? Now based on these three rules, let's see if we can do some questions. So the first question here is, I'm going to explain. Here is the first question. If there will be any extra point we need, I will explain that as well. So this is the first. Here we can see something extra given over here. Let me try the another question. There is one question like this also. Here, if you see all the three questions, they have some tangents here. So before we start this one, it's good practice to go over the tangent part also. So let's go to that one as well. So we have done the 3 points. Now we are skipping the rule 4 for now. And I'm going to explain the rule 5 and then the rule 6. This rule 6 we are using a lot. So what is this rule says here? Rule 5 and rule 6. Rule 5 is related to the tangent. Now what is the meaning of tangent first of all? Tangent is what basically, let's say you draw any curve. You draw one straight line that touches exactly one point. So this line is a tangent. Same way, we know that a circle is like a curve. You take any point on this curve and you draw this tangent. And then from the center, we draw one radius and at the same point it is touching as we have drawn the tangent. So the first rule, it connects the radius of the circle and the tangent line. And what is the rule? It connects through an angle, that the angle made between the radius and the tangent to the circle, this is always 90 degrees. Or radius is perpendicular to the tangent. When the angle between two lines is 90 degree, we call that the two lines are perpendicular. So this is the radius line, this is the tangent lines, the angle between them is 90 degrees. So we say that radius and tangent, they are perpendicular. Okay. Then the next thing is, if you have a circle, let's try one circle. Let me draw one circle here. So this is a circle. I take a point which is outside this circle. So let's say I am taking this point here. Now I am going to draw two tangents. From this particular point, I can draw tangents to this circle, and tangents are the lines which can touch the circle at exactly one point. So I try to draw the tangents now. One is this. I use straight line here. So this is more appropriate. And then I can draw one more here. After that, I can see I cannot draw any other tangent. So from a point outside the circle, let's say this point is P, you can maximum draw only two tangents. Let's say this is point A and this is point B. So you can maximum draw only two tangents. And again, if I draw the two radii at these points where the tangents are drawn, then I can say the angle between this radius and this tangent and angle between this radius and this tangent, they both will be 90 degree each. Okay, so there are two theorems based on the tangents. First is that these two lines, the angle between the radius and the tangent is always 90 degree. From a point outside the circle, you can draw only two tangents, and these tangents whose names are PA and PB, they are equal in the length. They will always be equal in length. We will do this proof also. Okay. Now let's go to some questions here. So this is the first question here given. And in this question, first of all, you have to look at the question carefully and observe what information is given. I can see there is a point A outside the circle, two tangents are drawn. O is the center of the circle. C is a point on the circumference. What they say, B, C and D, B, C and D, these are the points on the circumference of the circle. Center is O. A, B and AD are the tangents to the circle. Angle DAB is 50 degrees. Work out the size of angle BCD. So we have to find out this angle. Now, if you see, this angle is made in the points B, C and D. So just imagine a chord like BD. So this chord, this is a straight line. Let me draw it as a straight line. Just imagine this BD is as a chord. This line is making this angle at the circumference. Now, one thing we know with relation to the chord and making angle at the circumference, there is no other point in the same segment. But there is a point O, which is the center of the circle. And we know one thing, that if I talk about this angle BCD, this angle is, if I double this angle, I will get the angle made by the same chord BD at the center. So that is angle BOD. Right? So from here, because I have to find out angle BCD, what I do, I make it, this will be half of angle BOD. Reason, we have to find out this angle. So now how can I find out this angle? Now another thing starts over here. This angle is given as 50. Right? This angle is given as 50 and this is the radius, this point and this point. This is the radius. So if Now I remove this side. Whatever information is given, you have to use it. So this angle will be how much? If I consider this angle, this one, this is the radius and this one is the tangent. This is 90 degrees. Same way, because why I am using this rule? Because I can see the tangents are there, I can see the radius are there, and I know this relation. So if I have to find out BCD angle, that means first I need to find out this angle BOD. But BOD angle, how can I find out? For that, I need to see what information is given here and I will make use of it. This angle is given 90 degree, and on the other hand, this angle will also be 90 degrees. Now, if you look at this quadrilateral ADOB, this is not a cyclic quadrilateral because all its vertices are not on the circumference. So only D and B is on the circumference, O is the center and A is a point outside. But because it is a quadrilateral, so we know that all the four angles will add up to 360 degree. And you have to mention in circle theorems, like if I will be writing that angle DAB, that is this angle, plus angle ABO plus angle BOD plus angle ODA. This is 360, and you will write here because angle sum property of the quadrilateral. This is a must to give the reason. Okay, even if it is mentioned in the question or not, you have to write it. Now angle DAB is given as 50 degrees. The two other angles are 90 each. And one angle which is at the center, DOB or BOD, that we don't know, but they all add up to 360 degree. So this is 180, 180 plus 50, that is equivalent to 230 degrees, plus angle DOB, and that is 360. So angle DOB is equal to 360 take away 230, which gives me 130 degrees. Now, once I got this angle 130 here, so I can say that angle BCD is equal to half of 130 degrees, that is 65 degrees. And hence our question is solved. I hope this is clear. So what did we do in this session? We covered three theorems or four theorems of circle related to circles. We understand what is a chord, what is the meaning of segment, minor segment, major segment. What is the relation between the angles made by the same chord in the same segment? What is the relation between the angle made by the chord at the circumference and another angle made by the same chord at the center? We also understand what is the meaning of tangent drawn to a circle. We know that the angle made by the tangent with the radius of the circle is 90 degrees, and we can at most draw two tangents to a circle from a point which is outside the circle, and those two tangents are equal in length. Based on all that, we solve this one question in our today's live session. Please watch this session. If you have any doubts, you can comment and get your doubts resolved. Thank you.